Welcome to the first lecture that I'll be giving about how to program within R. You'll note that I have RStudio up in R, as a program. And RStudio is a program that will allow us to better handle programming tasks in R. So it will execute R code with a console. So if you just open up basic R, R just provides a console, and it stores output and graphs and things of that nature. That's what base R does. So if I were to go to my Finder here and go to Applications, if I were to just pull up base R and open it up here, you can see that it is just provided a console, okay? And I can see what's in a workspace, potentially install packages if I need to, do a little bit of data management, but long story short is I'm just dealing within a console, okay? And it is what it is. So I'm going to X out of R. I'm not going to save this workspace image. And instead I'm going to work within the context of RStudio, which is what I have open. So RStudio will take our code. It will compile it with a console. So you can see down here in the bottom left, we have a console. But it also provides an interface to look at other components of our programming tasks that we may want to observe rather than just executing code. So one of the problems with just having something where we execute code is that while you have the code, you don't necessarily save your code. And saving the code is often as important as writing the code itself. So we want to be within a program where we can actually save it. So let's look at that. So within RStudio, here's the program. Here is the set of tasks that you can achieve. I want to point out that we're mainly going to be creating new files. So you can do a number of different things. You can do R Markdown, R Notebook. Right now we're just going to be doing basic R scripts. So think of a script as something similar to a Word document or an Excel spreadsheet. It's a deliverable that is where you're going to store the information that you want. So an R script is stored code. Okay, and so if I want a new R script, I just click File, New File, R script. If you want something else, if you want to make a text file or maybe do something in C++ or some of these other more complicated or I don't want to say more complicated, but different languages or different components of R, you could. Right now we're just going to be dealing with an R script, although we'll look at some of this stuff to the extent that we get a chance. Okay, so I have a blank canvas for where I can code in R. This is the R script. If I type in commands in R, I can do it directly in the console. I can type something into the R script and run it, and that line of code will show up in the console, and R will run that line of code, but it will save that line of code in my script. So RStudio provides us with a script editor in the top left and a console in the bottom left. And then it provides us with just a whole bunch of information on these sides. So we can look at different plots that we make or different packages that we've installed to do different things. So as you can see here, I've installed a number of different packages, and we'll work on installing packages ourselves as we need to during the course of this class. You can look at help. So here I pulled up some help. I wanted to learn a little bit more about making smooth kernel density estimates of scatter plots. I pull that up right here. and there's a viewer. The environment is where we store objects that we make with our R script. So I can use R script. I can put code into R script. I can run it. I can create some mathematical object, and that will be stored in the environment. Okay, and so the environment right now is empty. I've cleared it out, but as you see, once we start making new variables, they'll show up in the environment. This gives us a little bit of history of what's been done in the console. Okay, and you can see here's a history of all kinds of things that I've done in the console as I've worked in R. Okay, so let's start with some basic code. The first thing I want us to get in the habit of doing is commenting in R. So to comment in R, we use what's called a hashtag. You may be familiar with this in other settings, but I can comment in R with a hashtag. Now, if I try to run my comment in the console, it just prints the comment, but nothing happens. So the comment is a description of the code which I use to explain to others how the code works. Note that when I run the comment in the console, R just prints the comment. It doesn't do anything else. So let's say I want to make a vector in R. C is a formula that I can use to make a vector. But let's say I just want to make a vector with 5 numbers in it called x. I type in x into the R script. This left less than sign, this hyphen, is an assignment rule. It assigns a particular function to x. So let's say I wanted the numbers 1 or 5 different numbers. Let's say C tells R that I'm making a vector. And I could do a vector like this: 1, 3, 5, 6, and 8. I run it. Okay, now R did something. So when I ran the comment at R, it printed, I ran it down here, it did something. But note that something showed up in the environment. It's this vector of numbers 1, 3, 5, 6, and 8 in R. So it's a vector. Now I have an object in my environment. That object is a vector of numbers from 1 through 5. Now I can find out what numbers I have in my environment using the print function. But right now I want to tell myself that I use the C function to make a vector with 5 elements. 1, 3, 5, 6, 8. Maybe I want to learn more about the vector. So I can use the print function. Print, you can tell when I type it into RStudio that it provides some insight as to how to use the print function. So when I type in print, print is a known command in R, and it gives me some insight as to how to use the syntax. So if you think about using Microsoft Excel, Excel actually does a very similar thing. When you start typing in a formula in Excel, it will return the syntax. And the reason R does this, and most programs do this, is because it's super difficult to remember the sequence or the syntax of everything. So let's say I just want to print x. Okay, I just typed that right in there. Now I've highlighted it. I can run it from the script in the console. And here, this is what x has: 1, 3, 5, 6, 8. Okay. So this lists the values of x. I can manipulate x. So I can create 2 times x. R's now multiplied x by a scalar, which is 2. So each element of x is doubled. There is not a new variable called 2x. Okay? The reason why is because we have not assigned a particular variable to this particular mathematical operation. So this is multiplying in R. But note, there's no new variable created. We didn't assign one. Okay, now let's look at y. Maybe I want to assign a new variable y that has 2x. Okay, I can do that. Run it. Now, I had multiplied x by 2, the scalar 2 previously, but now y is those variables listed in R. I can find the mean of x. Mean is a function for the arithmetic mean. Okay? So if I find the mean of x, I can run it, and it's 4.6. Note that I haven't assigned a variable to this. I just used R to perform an operation. Maybe I could find the mean of y. We should think the mean of y is 9.2 because it's 2 times x. There it is. Now let's say I wanted to evaluate the expectation of x and y. I can do that in R. I rename it expectation of x and y. I can just add the 2 means together. Each value is weighed the same. I do that here. I run it. And you can see that now I have made a new variable called the expectation of x and y with value 13.8. So you can use R as a calculator. Here I'm using it as a calculator. Perhaps I want to do something more mathy. Maybe we can find the sine of x. These values for x are not treated as degrees necessarily, but they are. So, well, I should backtrack. These will be treated as degrees in the sine function. So the sine of x is going to have 5 objects. They're all going to be pretty small. Okay. I can print sine of x. There we are. So R doesn't treat these as degrees. Okay. You may note that I've been not adhering to coding. So I need to go back and comment some of this code. The mean function finds the mean of a particular variable. Here we made a new variable. Expected value of x and y. Here we made a new variable. R treated the values of x as radians. I think it treats the values of x as radians. Okay. Maybe I can plot x and sine of x together. I can do that with the plot function. Okay. We would run it. Now I have made a plot of x versus the sine of x. Okay. You see, it looks a little bit like a sine function. Okay. Over here is the graph. If I want to learn more about the syntax for help, I can type in help plot into the console. So it seems like maybe I could do more with this plot function. And I can type help plot into the console, and I can just learn a little bit about generic XY plotting. So here's the usage. This is how we used it. Plot x sine of x versus plot xy. But there are arguments that we can make. So we could do a type of plot. So you could generate a histogram if you had a lot of data. You can title the plot. You can give it a subtitle. You can label the axes in different ways. Here are some examples where people do more. And note that you can see the coding for these plots. The title function will describe all the stuff that you might like to add to a plot. So main, subtitle, x labels, y labels, etc. And we can just go back to the plot here. This is just a very basic scatter plot that R made. A couple of comments that I would make about the plot function within R. If you take a look at the export here, you can save it as an image, a PNG, a JPEG, a bitmap function, a TIFF encapsulated PostScript. You can mess around with the width automatically. If you wanted to maintain an aspect ratio, it would lock in one of the two sides as you reduce the other side, so it would maintain the same type of resolution. The directory is where you choose to save it. Here I just have it saved in my downloads, my main directory, but you can choose whatever directory you want. You can save it as a PostScript, or a PDF. You can copy it to a clipboard. So the plotting function in R is really powerful. This is the simplest possible function, but already you have a relatively useful interface to manipulate it. We didn't do anything exciting to add to the function, but we certainly could have. You can clear the plots with the eraser here. Or I think this is a broom. You sweep it out. Okay. So I have 3 variables here. I can make a data frame. Let's call it data 1. I'm going to assign it this data frame. Note that right now, x and y and sine of x are just different vectors within R. There is nothing that relates them to each other. So there is, although when I plot x versus y, it plots the numbers in the order of the vector, they're not necessarily tied together via an observation. So I can do that with the data frame. Okay. Can run it. Data frame just collects all the different variables that I have and puts them into one data set. Now note that these were values described as vectors, but now there is a new object type called data. I can double click on it and I can see the data that I have. Okay, so you can look at a data set within R, and you note that when I double clicked on the data set, take a look at the console actually did something. It viewed the data. So if I wanted to view the data, I just type in view data 1. Okay, that data frame is now placing our vectors into an object that we can use to do statistical analysis. So in essence, what the data frame did is it created a cross-sectional data set. So what we can actually do here is just comment that. Okay, and this plot function again made a scatter plot. Okay, now we can actually use R to import data that we have here. So I collected some data on Mike Trout using baseballreference.com and I put it into my downloads. Okay, so I'm going to call it Trout for Mike Trout. He's a baseball player. It's a data frame, but the data were already collected as a cross-sectional data set. I collected it as a comma separated values cross-sectional data set. So maybe I can show you here if we go back to baseballreferences.com. I type in Mike Trout. Okay, here he is. Hello. You can know he's having a little bit worse year because he's tired. The Angels are not very good. But let's say we go to get table as CSV. Okay. Now here are the data. I may not want all of the data. I just want the numeric data. I don't want this last thing, which is non-numeric. I can copy it. I go to any program we want, we'll do this, but if I went to like go to Notepad or something like that, I think in Mac it's called Text Edit, but in Office it's Notepad. I don't need to open a file, but I can do a new text, just paste the data in. You can call it save. Now when I save it, this is the important part. Let's say I go just save it where my data are located. This is the directory I've been using for R, this msynchy directory. No extension is provided. It will save it as a .txt, which is not a readable data file for R, or not the one that we're going to use. But I want to save it as trout1.csv. I'm going to put it right here and save it. There it is. I've saved it. Now I want you to see what happened at the top is that the file format actually changed, and you can see the little Excel icon. It changed to something that could be opened with Microsoft Excel, but we're going to use R to read it in. Okay, so I go back to RStudio and I type in read.csv. Okay, and the data file is trout1.csv, comma, header equal true. The header indicates whether or not the variable name is the first row of the data set. Separation tells R that my data are separated by columns. This is good enough for now, I think. We can run it. Should work. There it is. It worked. You can see that if I double click on the data set, I can view it here. Okay. Now I have collected Mike Trout statistics. I can go back to look at the data, but I want to comment. I created a cross-sectional data set for Mike Trout by reading in a comma-separated value. This is an example of what I meant when I said that the data, even if there is a time series component to it, is treated as cross-sectional. So by downloading all of Mike Trout's seasons in this manner, I have treated the data as if it were cross-sectional, even though there is a clear time series component to it. So that is something we're going to have to think about. There's a function in R called sapply. Okay? And the sapply function will describe the data set. I think I have used the sapply function wrong. Let me do it again. I forgot to put the class. So what I just want to do is summarize a little bit of the features of the Mike Trout data set. Okay, so there was no function. I forgot to put the function. I wanted to describe the class. So some of these are character variables. You can see that age is a character variable, and that may be a problem for us that we need to fix. So even with very small data sets, you often run into problems that can be challenging to fix. That's something we're going to try to deal with some in this class, and hopefully you'll get to do more of that in econometrics with Dr. Smith. But this describes the variables. Okay, we can estimate a regression even with these variables. We can estimate, we'll name the regression. LM is a linear model. How we get variables out of our data set that we've created is, you can note that when I estimate a regression, I have data 1 and I have Trout. Okay. R doesn't know, based just on this regression, that if I want to pick a variable out of the Trout data set, that that's actually what I want to do, because I need to tell R what it is that I want to do. So maybe I want to estimate stolen bases, which is an integer, as a function of plate appearances. So SB is the Y, and plate appearances is the X. I tell R that I want to do this. I do Trout $. The $sign tells me that I'm going to pick a variable out of the Trout data set. So I click stolen base. The tilde is the X variable. So this is estimating the expected value of Y based on X. I just run it. Now you can summarize this regression using summary and run it. This will tell you the slope and the intercept. I think this is all we're going to do for now. Just kind of warming you up a little bit with what R could do, and we go from there.